let's understand how a transistor can be used as an oscillator. Look at this particular circuit. See, now here you have that inductor L and you have another inductor L1, correct? Now L is connected to the base emitter circuit, and in base, EB circuit. L1 is connected to the collector emitter junction, as in that particular circuit. Now what we have one capacitor which is connected to an inductor. Basically you have LC circuit. Now when you have that LC circuit, you have LC oscillations, correct? That means, if you remember from AC chapter, there we had understood what was LC oscillation. Just to quickly recap what it was. Capacitor used to charge, that used to give the charge to the inductor. Inductor used to have the magnetic field. Magnetic field again by Lenz's law used to charge the capacitor back in the opposite direction. This was basically LC oscillate or LC oscillations, correct? Now here, how a transistor also behaves like an oscillator. That is what we are trying to understand. Alright. Now first, once the key is closed here, the charges will start to move. And as they start to move, what's going to happen in the beginning? First, the collector and the emitter. So you have these two, correct? The emitter current will start to increase. Once the emitter current start to increase, that is IE starts to increase, that L is there, correct? The inductor. So inductor is connected to the emitter base junction, isn't it? The emitter base junction will start to have forward biasing, correct? The forward current will start to move. As the forward current starts to move in that inductor capacitor circuit, that particular part of the circuit, the capacitor starts to get charged, correct? One more thing is, as IE increases, IC will also increase, the collector current will also increase, correct? So first thing, what is happening? The emitter base junction is under forward bias, the emitter current increases, collector current increases, and the capacitor, the upper plate of the capacitor, that starts to become positive in nature. In the sense, between L and L1, there is magnetic coupling. So as the coupling starts to increase, the capacitor will also keep on charging. Once that induction stops, the capacitor no longer charges, it's going to stop charging. Okay, now what's going to happen? As this particular circuit or this part of the circuit is done, that is, till the magnetic induction between the two inductors, that has stopped. It no longer, the coupling stops basically. Once the coupling stops, then the magnetic field will start to reduce, correct? That means it was increasing till now. Now it starts to reduce. As it starts to reduce, the emitter current will start to decrease. Gradually it starts to decrease, correct? So the collector current will also start to decrease. And once that starts to decrease, what's going to happen? See, the capacitor will start to discharge, correct? That means the emitter base junction is no longer under forward biasing. That gradually changes. As that gradually keeps on decreasing, so the magnetic field lines will start to decay, or magnetic field lines will start to collapse. According to the Lenz's law, what's going to happen? The lower plate of the capacitor, that will start to become positive in nature, because the current direction will reverse, right? Isn't it? So again, the same cycle will go. So IC reduces, IC will become 0. Again, in the next half of the cycle, IC is going to become maximum. That means here what's happening? The collector current, IC, it varies from maximum to 0. So this acts like an oscillator. This is why we say that a transistor behaves like an oscillator. Clear? So these are the three uses what we have: as a switch, as an amplifier, as an oscillator. Okay. So these are the main three uses. I mean, there are a lot of other uses also, but these are the three main uses what we have for transistors. Okay, now let's try to understand what is logic gates and digital electronics from the next video.